Good afternoon to Dr. Johanna and my dear friends. Today we are from Group 9. We'll explain and present about our experiment 1, which is stability of floating body. Before that, let me introduce ourselves. My name is Faden. I'm the group leader alongside with Siti Nurantasha binti Suhaimi, Nurul Nafisha binti Nur Zamran, and Pavitra Anapupan Chandra Mohan. So this will be the contents of our presentation, which is summary, theory, procedure, data and analysis, result and discussion, and conclusion. So I'll start off with the summary. So basically, the potential energy of a system in stable equilibrium has minimum value. This property is used to derive a formula that is useful in determination of stability of a floating body. The vessel or body that appears to float on water is very necessary for balancing and stabilizing. It is found that a floating body is in stable equilibrium if its center of gravity has a minimum height with respect to its related center of buoyancy. It is possible to assess a float's stability by its metacentric height. The metacentric height, which is known as GM, is a measurement of initial static stability of a floating body. To be specific, the distance between the center of gravity of the body and its metacenter is known as metacentric height. In tipping, greater stability results in more metacentric height. In order with that, this experiment was performed using the tilt method to assess the height of the metacenter of the pontoon. The results from the measurement method for test 1, test 2, and test 3 are 80.61 mm, 109.11 mm, and 133.61 mm respectively. Although the test 1, test 2, and test 3 graph results are 37.7 mm, 62.28 mm, and 82.06 mm. The results obtained by the experiment illustrate the relation between the center of gravity core and the leaf center. The metacenter descends toward the bottom of the float as the center of gravity moves to the left. It is important to have the knowledge on the stability of pontoon, such as a floating ship. Whether the equilibrium is stable, neutral, or unstable is determined by the height of its center of gravity. In this experiment, the stability of a pontoon may be determined with its center of gravity at various heights. Results obtained can be compared with calculation methods results. Next theory, I let it to Nafisha.
Alright, so I am Nafisha and I am going to explain about the theory of this experiment. So firstly, a floating body is said to be stable if it returns to its original equilibrium position when it is displaced to a new position due to small disturbance such as waves. However, a floating body is said to be unstable if it moves to a new equilibrium position when it is displaced. Next, the stability or instability of a floating body can be determined whether by writing or can also be said as restoring or overturning movement is being developed when the center of gravity and the center of buoyancy move out of the vertical alignment of the floating body. Next slide. These two figures show the stable and unstable configuration of a floating body when it is being displaced. First, I will explain about the stable configuration. So, any inclination of a floating body will result in turning moment. A floating body can also be stable even when the center of gravity, the CG, lies above the center of buoyancy. This is because as the floating body rotates or displaces, the center of buoyancy will move to a new position as the shape of the displaced volume changes. The buoyancy force, the FB, will then act on the centroid of the new volume displaced, and thus the buoyancy force FB form a restoring couple with the weight of the body as they are equal in magnitude and opposite in direction. Hence, the floating body will return to its original equilibrium position. Meanwhile, if the body is relatively tall and slender, a slight rotational displacement will cause unstable configuration of the body because the buoyancy force and the weight form overturning couple. Next slide. So, metacenter is a theoretical point at which an imaginary vertical line passes through the center of buoyancy and center of gravity. Metacenter can also be defined as a point at which a floating body tries to oscillate. Besides, the distance between center of gravity and metacenter is referred to metacentric height. So based on the diagram shown, we can see the relationship between the metacenter and center of gravity. So when the metacenter is above the center of gravity, the floating body will be stable. But when the metacenter is below the center of gravity, the floating body will be unstable. And when the metacenter is on center of gravity, the floating body is in neutral equilibrium. So next slide. So for the theory of the experiment, the stability of the pontoon is affected by the value of center of gravity at different heights and also the angle of tilt. So when the horizontal weight is moved at a distance from the center, it will cause the pontoon to tilt. The angle of tilt can be measured by using the plumb box. So the equilibrium condition of the floating body can be determined experimentally by using the following equations. So these are the equations to find overturning couple, righting couple, and also equilibrium condition of the floating body. So then the results obtained from the experiments can be compared with the calculation method. We will use the calculation of the area of second moment to find the metacentric height of the floating body as shown in this slide. So that's all for me. I will pass to Pavitra to continue our presentation.
Hi, I'm Pavitra and I continue with apparatus. The apparatus we used is pontoon and a pillar with horizontal and vertical weight, roller, pontoon stabilizer, and water tank. Next, the procedures are: firstly, the horizontal weight is removed and the pontoon mass is attached to the height of the vertical weight. The second step is the center of gravity, which is known as CG, is determined by placing the pontoon mass on the pontoon stabilizer. The length of CG, which is half of the gap, is measured. The third step is it fixes the horizontal weight and ensures that the thread is located at 0 mm with no tilting. Next, the tank is filled with water and pontoon is placed inside the tank. Next, it tests the length of the pontoon which is immersed in the water. The sixth step is the 10 millimeter horizontal weight is shifted to the right and the thread tilt angle is registered. Step 7, by moving the horizontal weight to the right of an increment of 10 millimeter, step 6 is repeated. The tilt angle is registered, and then the move is repeated until the pump box hanging on the thread hits the height of the pontoon. Eighth step is this time step 6 and step 7 are repeated by shifting the horizontal weight to the left. And finally, the vertical weight is modified to a new height and step 1 to 3 are repeated and step 5 to 8 are followed. The test was performed using two different vertical heights values. Next, I would like to pass to Antasha.
Okay, so I'm Antasha. So this is the results that we get from the experiment for the test 1, test 2, and test 3. So yeah, this is the result. Okay, next. Okay, so for discussion, first we have to do the graph GM against the angle of tilt for each test. For test 1, the graph we get the GM is 37.7 millimeter when 0 degree angle. The y-intercept is 37.7 millimeter. Okay, next. For test 2, we this is the graph that we get. The value of GM that we get is 62.281 millimeter when 0 degree angle of tilt. Okay, next. Okay, for test 3, the value of GM that we get is 82.058 millimeter when 0 degree angle of tilt. Okay, next. Okay, so for the calculation for the metacentric height for each test is first we are given the data, which is the mass of horizontal weight 0.28078 kilogram. The total mass of pontoon with vertical weight 1.16567 kilogram. The weight of pontoon 0 0.2 meter. So we convert it to millimeter, which is 200 millimeter, and the length of pontoon is 350 millimeter. The density of water is 1 times 10 to the power of negative 6 kilogram per millimeter cube. So by using the area of the second moment formula, so which is Bm, which is I over V minus Y plus D over 2. Okay, so next. Okay, so for the test one, we the calculation GM is we get 80.61 millimeter. For test two, we get the calculated GM, which is 109.11 millimeter, and for the test three, we get 133.61 millimeter using the formula of the area of second moment. Okay, next. Okay, so this is the comparison between theoretical and experimental value of height of metacenter. So there are two methods to obtain the height of metacenter, which are using the tilting method and calculation method. So by the tilting method is done by repeating the center of gravity CG at different heights, and the angle of the tilt are recorded. Then we plotted the graph accordingly to the data. For the second method, we calculated LGM using the given formula area of second moment. Uh, okay, so both data prove that the lower the center of gravity, the higher the value of GM. Okay, so next. Okay, so this is the errors. The errors might have occurred while obtaining the data because there are great differences between the experimental values and the theoretical values, just like the previous slide. So one of the errors are, firstly, are the parallax error. So which we have to make sure that the eye must be perpendicular to the scale of the steel ruler to avoid inaccurate reading. So the second one is the disturbance due to the water and air can also affect the measurement. So to obtain more accurate result, we have to conduct the experiment in an ideal condition. Okay, so lastly, the wavy water surface had also increased the difficulty in obtaining the reading. Okay, so next. Okay, so next, the reliance of the metacenter on the position of the center of gravity in terms of stability of floating body. So the stability increases with the distance between the metacenter and the center of gravity. A restoring pair is created by the buoyancy force and the weight of the body that helps to turn the body back to its original position when the metacenter is above the center of gravity. The metacenter remains directly above the center of buoyancy regardless of the tilt of a floating body, which makes the floating body is in a stable condition and have greater stability. If the metacenter is below the center of gravity, the floating body will become unstable and a tilt results in capsizing. Okay, next. Okay, so this is the effects of variation in angles of tilt on the position of the metacenter. The position of metacenter will be different due to the tilted angle of the floating body. The center of buoyancy shifts to a new location when the body is rotated. Gm is inversely proportional to angle of tilt. When the angle of tilt increases, the value of metacenter height Gm will decrease, resulting in a decrease in the floating body stability. So this is depends on the equation, which is Gm equals to Wx over W tan theta. Okay, that's all. Then I will pass to Pavi.
For the last part of the slide, I would like to present conclusion. The state of equilibrium of a solid body, partially or fully immersed in a liquid or gas, is called floating. The theory of constant principality is assumed to be stable at its place if it returns to the position after a small disturbance. The experience shows how an increase in height of its center of gravity affects the stability of floating body, and the metacentric height is experimentally taken by moving the center of gravity across the body sideways. We carry out this experiment to determine the metacentric height by varying the metacentric height with angle of tilt. In this experiment, we use different heights to measure the stability of floating bodies in stable and unstable equilibrium state. The GM values for test 1, test 2, test 3 are 80.61 mm, for test 2, 109.11 mm, and 333.61 mm, respectively, based on the measurement of the metacentric height, GM, for all three experiments. For each test, the tilt angle increases and the metacentric height decreases as the center of gravity, G, increases in height. This results a decrease in the stability of the floating bodies. When the weight curve is applied, the value of least angle increases as time is passes. This makes the floating bodies become unstable. The value thus defined satisfactorily agrees the given by the Bm equals to I over V analytically result. That's all from us. Thank you.